The last few lessons we've been working on equations, and what we know is an equation has an equal sign. So you'll notice this lesson, lesson 12 in module 3, is on properties of inequalities. So we're going to talk now not about equals, but about these symbols. Okay, so I know you've seen these before, but it's a good idea to write them down just so in case we kind of forget what they mean. This one here, okay, this one means less than. Whatever is here is less than this side. I always think of it like the point, it's pointing to the smaller one, or the tip is at the smaller one where it's open and bigger. It's at the bigger number. And if that means less than, then this one here means greater than. And now notice these look really similar, except we have a line underneath. So this one also means less than or equal to. Okay, and this is not a choose if it's less than or equal to. It's one or the other. Okay, it can be either less than or equal to, and it answers the makes it a true statement. And so likewise, this is greater than or equal to. Or equal to. Okay, so a couple other terms we need to be familiar with that we're going to be talking about today. Because again, we're just talking about properties of inequalities today. We'll get into the solving them and graphing them and all that stuff later on. But we're going to be talking about the words preserving and reversing. Okay, preserves, reverses. So if we say we preserve the inequality symbol, it stays the same. And this will make more sense as we get into some examples, but I want you to write this down. If I say it's preserving the inequality symbol, it stays the same. It doesn't change. Whereas if it reverses the inequality symbol, we're going to say it switches directions. All right, and as you're going to see in some of these examples, some of these less than, greater than, less than or equal to, greater than or equal to, excuse me, that doesn't hold true when we do our operations of adding, subtracting, multiplying, dividing. And the best way to show you that is to do some examples. So we're going to pretend we're set up at different stations here, and you'll notice it says like die 1, die 2. That's dice, right? We're rolling dice and getting numbers, and we're going to pretend we're doing that. But at station 1 here, the first thing we're going to be working on, we're going to be working on if we were to add or subtract numbers. Okay, so they gave us an example here. This is what it means. -3, and if we roll the second die, right? Dice, singular is die. We rolled a -3 and a 5, we would say that -3 is less than 5. Okay, and picture number lines. If you struggle with positive and negative numbers, picture number lines. Let me know. I'll get you a number line. You could just keep it with you if that's going to help you. Further to the left is smaller, further to the right is greater. So the operation we're going to do is we're going to add 2. Now remember, in equation, if we added 2 to one side, we have to do it to the other. The same thing is true for an inequality, okay? Because remember, if it's true to begin with, then whatever you do to one side, you got to do to the other. So if you look right here, here's my -3 and my 5, right? We had -3 is less than 5. And then notice what we did here is we added 2 to each side. Okay? So if you add 2 to a -3, you get a -1. If you have 2 to 5, you get 7. Notice we wrote, or they wrote, preserved here. And what that means is our inequality symbol was less than to start. And notice when we get -1 and 7, -1 is still less than 7. The symbol was preserved, stayed the same. All right, so let's try another example. And we're going to pretend that I rolled some dice here and I got the numbers 4 and 6. Okay, so thinking of the number line, or just what you know about numbers, I hope you would say that 4 is less than 6. Now we're going to add a -3. Okay, so we're going to start with 4 is less than 6, and we're going to add a -3 to both sides. 4 plus a -3, that is a -3. That looks really sloppy. And we're wondering, is that still less than 6 plus a negative 3? Okay, well, 4 plus a negative 3, go up 4 to number line and come back 3, you're at 1. And 6 plus a negative 3, if you go up 6 and come back 3, you're at 3. So 1 is less than 3. Is that a true statement? Yep, we'd say the sign is preserved. Okay, again, we added negative 3 to both sides, and the inequality symbol held true. 4 is less than 6, we add negative 3, 1 is less than 3. Okay, so another example. Rolling my dice here, and I'm going to get a 6 and a negative 1. I have special dice that have negatives on it too. All right, so if you think of 6 and negative 1, 6 is further to the right on the number line than negative 1. So we say that 6 is greater than negative 1. So I would start with 6 is greater than negative 1. Now I want to subtract 2 from each side. All right, so I'm going to start with my 6, then I'm going to subtract 2, and I'm wondering, is that still greater than negative 1 minus 2? Subtracting 2 from each side. Well, 6 minus 2 is 4. Now a negative 1 minus 2, or a negative 1, keep, change, plus a negative 2 is a negative 3. So think of the number line. Is 4 greater than negative 3? Yes, it is. So 6 is greater than negative 1. I subtracted 2 from each side, and I get 4 is greater than negative 3. That inequality symbol is preserved. It stays the same. And I know you might be thinking, but isn't it always going to be the same? We'll get there. One more. Okay. Rolling my dice here, and I get a negative 5 and a 1. Thinking of the number line, negative 5 is less than 1. Okay, and what I'm going to do here is I'm going to subtract a negative 1. Subtract a negative 1. Okay, so here's my negative 5, and I'm going to leave some space here because I'm just going to write in my work in between here. Okay, so negative 5 is less than 1, but now I'm going to subtract a negative 2. Whatever I do to one side, I'm going to do to the other. Not a negative 2. I apologize. I'm going to subtract a negative 1. Okay, so now, and I'm wondering if my inequality symbol is going to be preserved. Anytime you see minus and negative, let's simplify it. Keep, change. Okay, this looks neater than this does. Keep the negative 5, change a minus to a plus, change a negative 1 to a positive 1. Okay, and then we say less than, keep, change. Subtracting a negative 1 is the same thing as adding 1. Okay, so if I add negative 5 and 1, and again, I'm wondering if my inequality is preserved, negative 5 plus 1 is a negative 4. 1 plus 1 is 2. Is negative 4 less than 2? It is. So again, we can say it's preserved. So now we just want to sum it up. It says examine the results. Make a statement about what you notice and justify it with evidence. All right, well, here's what I notice. Whether I was adding positive numbers or adding a negative number or subtracting a positive or subtracting a negative, my inequality symbol is always preserved. So, you know me, I'm going to choose to type it out here because this is our statement. If A is greater than, maybe I can do this, is greater than B, or A is less than B, then if you add or subtract any number, the inequality symbol is preserved. Okay. If A is greater than B or A is less than B, and we've done them both. Here, A was greater than B. This A and B are the two dice, right? The two dice I threw? Two dice, I don't know. Okay, so it doesn't matter if A is greater than B or A is less than B. If you add or subtract any number, the inequality symbol is preserved. Okay, the inequality didn't change. If one number was less than another number, whenever you added or subtracted the same thing to each side, it stayed less than. That's not always going to be the case as we go through our different operations, okay? But please note, for adding and subtracting, if you add or subtract any number to both sides of an inequality, your inequality symbol is preserved. It stays the same.